August 7, 1945, the morning sky over Hiroshima split open with atomic fire. But 3 days earlier, on August 4th, another technological marvel had already been rewriting the rules of aerial warfare over the Japanese home islands. High above the clouds where oxygen grew tea, Hin and temperatures plummeted to 40 degrees below zero. A formation of Boeing B-29 Superfortresses cruised at 32,000 feet, utterly untouchable by Japanese defenses. The pilots inside their pressurized cabins breathed easy, while their adversaries below struggled against an invisible technological barrier they never anticipated, the Turbo-Supercharger. The story began years before Pearl Harbor, in the research laboratories of General Electric in Lynn, Massachusetts. Engineers had been wrestling with a fundamental problem of aviation as aircraft climbed higher. Engines suffocated in the thinning atmosphere, losing power with every 1,000 feet gained. Sanford Moss, a mechanical engineer who'd immigrated from Santa Fe, ran Cisco's academic circles to GE's industrial heart, had devoted his career to solving this puzzle. His solution seemed almost absurdly simple in hindsight. Use exhaust gases to spin a turbine that compressed incoming air, forcing it into the engine at sea-level density regardless of altitude. Japanese military strategists, meanwhile, had built their entire defensive doctrine around altitude limitations. Their intelligence reports from the late 1930s suggested American bomber technology lagged behind. Their own Mitsubishi designs, the Nakajima Katy for fighters and Kawasaki Ki-61s, represented the peak of their engineering capability. Optimized for combat between 50 and 1,000 and 25,000 feet the ceiling, they believed would constrain any bombing campaign. When American B-17 Flying Fortresses first appeared over Europe in 1942, operating at 25,000 feet, Japanese observers noted the altitude with concern but not alarm. Their fighters could reach those heights, albeit with difficulty. What Tokyo's war planners never imagined was Boeing's XB-29 prototype, which first lifted off from Boeing Field in Seattle on September 21, 1942. Test pilot Eddie Allen pushed the massive aircraft through its paces, and the data astonished even Boeing's own engineers. With 4 Wright R3350 duplex Cyclone engines,
each equipped with dual turbo-superchargers,
developed from Moss's original patents, the Superfortress could maintain full power output at altitudes where Japanese fighters gasped for air like drowning men. According to declassified Army Air Forces documents held at the National Archives in College Park, Maryland, the strategic implications were immediately apparent to American commanders. General Henry Hop Arnold, commanding general of the Army Air Forces, recognized that altitude superiority would translate into operational immunity. The B-29 program received unlimited priority, consuming resources that might have built 3,000 conventional bombers. The first combat deployment came on June 5, 1944. When B-29s from the 20 Bomber Command struck Bangkok from bases in India, Japanese intelligence officers reviewing the raid reports initially dismissed the altitude figures as errors or propaganda. Surely no foreign bomber could sustain operations above 30,000 feet for hours at a stretch. The laws of physics, as they understood them, simply didn't permit such performance. Their disbelief would prove catastrophic, a technological blind spot born from underestimating American industrial ingenuity and the revolutionary potential of turbo-supercharger technology that had been hiding in plain sight since the 1930s. November 24, 1944 marked the moment when theoretical advantage became devastating reality. Captain Robert Morgan, the same pilot who'd made Memphis Belle famous over Europe now, commanded a B-29 named Dauntless Dottie as part of the first mass raid against Tokyo since Jimmy Doolittle's audacious carrier-launched strike in April 1942. This time, however, the bombers approached not from suicidal low altitude, but from the stratosphere itself, where Japanese defenders discovered their nightmare had taken physical form. The turbo-supercharger system that gave B-29s their celestial advantage operated on principles that Sanford Moss had refined over 3 decades. Each of the Superfortress's 4 engines featured 2 turbine units mounted in teardrop-shaped nestles beneath the wings. As exhaust gases scream out of the engine cylinders at temperatures exceeding 1,000 degrees Fahrenheit, they spun turbine wheels at speeds approaching 20,000 revolutions per minute. These turbines drove compressors that rammed air into the engine's intake manifolds, maintaining sea-level atmospheric pressure even at altitudes where unassisted engines would produce barely 40% power. Japanese engineers, despite their considerable expertise in aviation technology, had pursued a different developmental path. Mitsubishi Heavy Industries design teams focused on lightweight airframes and power. UL engines optimized for a lower altitude performance. Their most advanced fighter, the Kawasaki Ki-100, could theoretically reach 33,000 feet, but only after a grueling 30-minute climb that left pilots exhausted and aircraft vulnerable. More critically, these fighters could barely maintain stable flight at such altitudes, let alone execute the aggressive maneuvers necessary for effective interception. Major Yoshio Yoshida, a veteran pilot with the Imperial Japanese Army Air Force's 244th Sentai, recorded his frustration in a diary later recovered by occupation forces. On December 3, 1944, he described attempting to intercept a B-29 formation over Nagoya. "We climbed to our maximum ceiling, engines screaming in protest. The American bombers eared as silver crosses perhaps 2,000 meters above us. We attempted pursuit, but our aircraft responded like wounded birds. The controls felt mushy, powerless. Meanwhile, those giants cruised serenely onward, untouched, unreachable. The stratospheric advantage extended beyond simple altitude capability. At 30,000 feet, temperatures dropped to 40 degrees below 0 Fahrenheit. But B-29 crews operated in shirtsleeves within pressurized, heated cabins, another innovation Japanese aircraft entirely lacked. While American bombardiers fine-tuned their Norden bomb sights in comfort, Japanese pilots who managed to reach interception altitude suffered progressive hypothermia and hypoxia despite oxygen masks. Their judgment deteriorated, reaction time slowed, and frostbite claimed fingers and toes. According to technical assessments published in the U.S. Strategic Bombing Survey conducted after the war, Japanese anti-aircraft artillery faced equally insurmountable challenges. Standard Type 88 75mm guns possessed theoretical ceilings of 30,000 feet. But achieving accurate fire at such ranges proved impossible with existing targeting technology. Shells required over 30 seconds of flight time to reach B-29 altitude, during which wind, temperature variations, and the Coriolis effect conspired to scatter rounds hundreds of yards from their intended targets. The psychological impact on Japanese defenders compounded their technical disadvantages. Ground observers watched helplessly as bomber formations drew perfectly straight contrails across blue skies, methodically selecting targets without apparent concern for the frantic defensive efforts below. Radio intercepts captured increasingly desperate communicate ions between fighter controllers and pilots, the latter reporting repeatedly that interception was simply impossible. Their aircraft wouldn't climb fast enough, wouldn't respond at altitude, wouldn't close the gap. The Turbo-Supercharger had created an invisible fortress around each B-29, an envelope of technological superiority that transformed strategic bombing from a dangerous gamble into an industrial process. January 9th, 1945 brought a crystalline winter morning to Tokyo, and with it came another wave of silver bombers tracking across the stratosphere. In underground command bunkers beneath the Imperial Palace District, Lieutenant General Torashiro Kawabe studied intelligence reports that painted an increasingly desperate picture. His staff had compiled detailed, anal assess of American bomber performance, and the conclusions were inescapable. Japan faced not merely superior numbers, but a fundamental technological paradigm they had never anticipated. The roots of this disparity stretched back to divergent engineering philosophies that emerged in the 1920s. American aviation development, driven by vast distances and commercial airline requirements, prioritized high-altitude performance and long-range capability. The U.S. Army Air Corps had funded Sanford Moss's turbo-supercharger research as early as 1918, recognizing that control of the upper atmosphere would define future aerial warfare. By contrast, Japanese military aviation evolved from the island nation's immediate tactical needs: carrier-based fighters for naval supremacy and agile interceptors for homeland defense, both optimized for the lower altitudes where dogfighting traditionally occurred. Mitsubishi's chief engineer, Jiro Horikoshida's Zero fighter later acknowledged this strategic miscalculation in post-war interviews. "We created the finest aircraft for the war we expected to fight," he reflected in 1953, speaking to American aviation historians. "Our Zero could outmaneuver any fighter at 15,000 feet. What we failed to anticipate was an enemy who simply refused to descend to our altitude. The Americans didn't defeat our aircraft. It made them irrelevant." The technical sophistication of the B-29's Turbo-Supercharger system represented decades of accumulated engineering knowledge. General Electric's refinement of Moss's original patents had produced a marvel of metallurgy and precision manufacturing. The turbine wheels, spinning at velocities that generated forces exceeding 50,000 Gs, required exotic alloy steels that could withstand both extreme temperatures and mechanical stress. The intercooler's hat prevented compressed air from overheating the engine's incorporated heat exchange, technology borrowed from refrigeration systems. Even the automatic controls that adjusted boost pressure as altitude changed represented cutting-edge electronics for the 1940s. Japanese industry, despite producing excellent conventional aircraft, lacked the specialized manufacturing infrastructure to replicate such systems. According to research compiled by aviation historian Richard P. Hallian at the Smithsonian National Air and Space Museum, Japan's Indust, Ryle Base operated under severe resource constraints by mid-war. Aluminum supplies were strictly rationed, high-grade aviation fuel was increasingly scarce, and the precision tooling necessary for turbo-supercharger production simply didn't exist outside Germany, and German technology transfer had effectively ceased by 1944. Captain Saburo Sakai, Japan's highest-scoring surviving fighter ace, encountered B-29s over Yokohama on February 19, 1945. His combat report, preserved in Japanese Defense Ministry archives, captures the frustration of even elite pilots approaching from maximum altitude. "I achieved a position perhaps 1,000 meters below the bomber formation. My Mitsubishi fighter was at absolute ceiling, controls barely responsive. I attempted to gain additional height, but the engine could provide no more thrust. The Americans maintained formation, completely aware of our presence, unconcerned. My ammunition would not reach them. I was a samurai, watching my enemy from across an unbridgeable chasm." The psychological dimensions of this technological gap extended beyond individual encounters. Japanese civilians, already suffering under conventional bombing raids, could see the B-29s passing overhead in daylight, their contrails writing messages of invulnerability across the sky. The Kempeitai, Japan's military police, reported declining morale among both military personnel and civilian populations. If Japan's defenses couldn't even reach the enemy, what hope existed for ultimate victory? The Turbo-Supercharger, a device most Japanese citizens had never heard of, was systematically demolishing not just cities, but the psychological foundations of continued resistance. March 9th to 10th, 1945. These dates would be seared into history as Operation Meeting House, the single most destructive air raid of World War II. Over 300 B-29 superfortresses descended from their usual stratospheric altitudes to between 5,000 and 9,000 feet, carrying not high explosive bombs, but incendiaries, specifically designed to exploit Tokyo's wooden architecture. The death toll exceeded 100,000 souls in a single night, surpassing even the atomic bombings that would come 5 months later. Yet this tactical shift downward actually proved the strategic value of high-altitude capability. The bombers could operate at low level precisely because earlier raids had destroyed Japanese fighter strength while remaining untouchable at 30,000 feet. Brigadier General Thomas S. Power commanded the lead formations that night, and his post-mission reports, now housed at the Air Force Historical Research Agency at Maxwell Air Force Base, Alabama, detail the calculated risk involved. Previous high-altitude operations had demonstrated our ability to strike with virtual impunity, Power wrote on March 11th. Japanese interceptor fork E's had been systematically ground down through attrition, not from aerial combat, which they could rarely achieve, but from futile climb attempts that exhausted pilots and destroyed engines. We descended to improve bombing accuracy against a defender we had already neutralized through altitude superiority. The irony was profound. Japan's aviation industry had responded to the B-29 threat by developing specialized high-altitude interceptors like the Nakajima KD-7 and Takakawa Ki-94, both featuring rudimentary turbo-supercharger systems reverse-engineered from captured German designs. But these aircraft entered testing only in late 1944 and early 1945, far too late to affect the strategic situation. Prototype test pilot Lieutenant Yohei Hinoki achieved 38,000 feet in a Ki-87 on April 1, 1945, a remarkable feat that would have been tactically relevant 2 years earlier, but was now merely a testament to engineering ingenuity arriving after the battle was lost. The human cost of Japan's technological disadvantage extended beyond military casualties. Civilian defense preparations had focused on conventional threats fire brigades, evacuation procedures, shelter construction, but offered no protection against attackers operating beyond the reach of defenders. Dr. Takashi Hoshino, who served as a medical officer in Tokyo's Fukagawa district during the March firebombing, recorded his experiences in a memoir published in 1958. "We heard the bombers approaching, their engines creating a sound like distant thunder. There were no air raid sirens because our radar had detected them too late, flying too high initially. When the incendiaries began falling, we had perhaps 5 minutes before the firestorm consumed entire neighborhoods." According to Japanese government statistics compiled by the Ministry of Welfare in 1949, the cumulative effect of B-29 raids between November 1944 and August 1945 destroyed approximately 40% of Japan's 63 largest cities. Industrial production, already strained by material shortages and labor conscription, call-up, set under systematic targeting of factories, rail yards, and port facilities. The aircraft manufacturing plants where workers might have produced high-altitude interceptors were themselves reduced to rubble by bombers. Those interceptors were designed to stop a vicious cycle enabled entirely by American altitude superiority. The psychological dimension of high-altitude bombing manifested in unexpected ways. Japanese radar operators could detect B-29 formations from great distances, providing ample warning time. But this advance notice served only to heighten the population's sense of helplessness. Citizens had time to seek shelter, to watch fighters scramble futilely upward, to observe anti-aircraft batteries waste ammunition against targets too distant to hit than to endure the bombing itself. Knowing their defenders had been rendered irrelevant by technology they couldn't match, the Turbo-Supercharger transformed strategic bombing from an exchange of violence into a one-sided industrial process. An asymmetry that corroded military and civilian morale alike far more effectively than propaganda ever could. August 6, 1945, dawned clear and warm over Hiroshima, providing ideal visual bombing conditions. At 08:14 local time, Colonel Paul Tibbitz's B-29, christened Enola Gay after his mother, released a single atomic bomb from 31,000 feet in altitude, made possible only by the Turbo-Supercharger. Technology that had dominated Japanese skies for the previous 9 months. The bomb, nicknamed Little Boy, fell for 43 seconds before detonating at approximately 1,900 feet above the Aioi Bridge, unleashing energy equivalent to 15,000 tons of TNT. In an instant, the technological advantage that began with exhaust-driven turbines culminated in nuclear fire. The selection of high-altitude delivery for atomic weapons was not coincidental, but absolutely essential. Manhattan Project scientists, working in utmost secrecy at Los Alamos, New Mexico, had calculated that bombers needed to be at least 8 miles away when the weapon detonated. To survive the blast effects, according to declassified documents from the Los Alamos, Shono Laboratory Archives, physicist Robert Serber explicitly specified in target committee meetings during May 1945 that delivery aircraft must release from altitudes exceeding 30,000 feet and execute immediate escape maneuvers to achieve minimum safe distance. Only the B-29 Superfortress possessed the combination of characteristics necessary for this mission: sufficient altitude capability, adequate range to reach Japan from Tinian Island, payload capacity to carry the 10,000-pound atomic bombs, and the pressurized crew compartments necessary for sustained high-altitude flight. Lieutenant Jacob Beezer, the electronic warfare officer aboard both atomic missions, later wrote in his 1968 memoir Hiroshima and Nagasaki, revisited that without turbo-superchargers, the atomic bomb would have been a theoretical achievement without practical application, at least not deliverable by air. Japanese radar stations detected the small formation approaching. Hiroshima that morning, 3 aircraft where previous raids had involved hundreds. Fighter Command initially assessed the group as reconnaissance aircraft, not worthy of scrambling precious fuel and pilot reserves. By the time the city's defenders recognized the threat, Enola Gay had already executed its bomb run and begun its violent escape turn, diving away from the release point to build airspeed. The remaining fighters of the 343rd Air Group at nearby Iwakuni Base never left the ground. The bomber's altitude made interception impossible, just as it had for 9 months of conventional raids. 3 days later, on August 9th, Major Charles Sweeney piloted Boxcar to Nagasaki after finding the primary target of Kokura obscured by clouds. Again, the mission profile demanded high-altitude delivery, this time 28,800 feet, due to fuel constraints. The plutonium core. Fat Man bomb detonated at approximately 1,650 feet altitude, destroying the Urakami Valley Industrial District. The combined chiefs of staff had prepared target lists extending through September and October, anticipating the need for 10 to 12 atomic weapons before Japanese surrender. All assumed B-29 capability to deliver from stratospheric altitudes immune to interception. Major General Masakazu Kawabe, commanding general of Japanese Air Defense Forces, surrendered to the inevitable on August 10th, when Emperor Hirohito recorded his capitulation announcement. In post-war interrogations conducted by U.S. strategic bombing survey teams, Kawabe acknowledged that conventional bombing had already rendered continued resistance untenable. The atomic bombs provided His Majesty with a reason to end the war that preserved honor. But truthfully, we had lost air superiority months earlier. We could not protect OU, our cities, our factories, our people. The B-NE-JUU-KYUU, the Japanese designation for B-29, flew wherever it wished, struck whatever it chose. Our fighters were like samurai facing rifles for the first time. The technological cascade that began with Sanford Moss's turbine designs in the 1920s had culminated in atomic holocaust. The Turbo-Supercharger made high-altitude strategic bombing practical. High-altitude bombing made conventional defense impossible. Impossible defense made continued war unsustainable. And unsustainability created the political environment where atomic weapons became acceptable. On August 15th, Hirohito's voice crackled over radio speakers throughout Japan, announcing surrender, the first time most citizens had heard their emperor speak. His message transmitted from a palace that B-29s had carefully avoided while systematically destroying the nation around it. February 12, 1943. More than a year before the first B-29 would strike Japan, a typed intelligence summary crossed the desk of Rear Admiral Tokajiro Onishi at Imperial Navy Headquarters in Tokyo. The document, translated from intercepted American technical journals, described Boeing's development of a new heavy bomber with unprecedented high-altitude performance. Onishi, innovative thinker, who would later conceive the kamikaze strategy, penned a marginal note preserved in captured Japanese military records. Investigate American turbo-supercharger development. This may represent a significant capability gap. His warning disappeared into bureaucratic channels, never generating the urgent response Japan's survival demanded. The intelligence failure that allowed turbo-supercharger technology to blindside Japanese defenses had multiple causes, all rooted in institutional assumptions that proved catastrophically wrong. Japanese military intelligence, despite its successes in other areas, fundamentally misunderstood American industrial priorities and capabilities, according to analysis by historian Joe H. N. Prados in his 1995 book, Combined Fleet Decoded. Japanese intelligence services excelled at tactical signal interception and code breaking, but struggled with technical intelligence that required deep engineering expertise. The concept that America would invest massive resources in altitude enhancement technology rather than simply building more numerous, conventional bombers struck Japanese planners as economically inefficient. Lieutenant Colonel Takashiro Hattori, staff officer in the Imperial Army's Operations Division, participated in war planning throughout 1942 and 43. In post-war memoirs published in 1959, he candidly acknowledged the systematic underestimation. We studied American bomber raids in Europe, and concluded they operated at altitudes our fighters could contest. Intelligence reports mentioned superchargers and turbo-superchargers, terms we understood technically, but whose strategic implications we failed to grasp. We assumed incremental improvements, not revolutionary capability. This was perhaps our greatest miscalculation. We prepared for the enemy we expected rather than the enemy America's industry could create. The institutional divide between Japanese Army and Navy Air Forces compounded the intelligence problem. Both services maintained separate technical intelligence sections with minimal information sharing, a dysfunction rooted in inter-service rivalry that bordered on hostility. When Navy Intelligence acquired fragments of information about toned B-29 development through diplomatic channels in neutral countries, Army Aviation Command remained unaware. When Army Signals Intelligence intercepted American communications mentioning high-altitude modifications, Navy planners never received the reports. The turbo-supercharger's significance fell between bureaucratic cracks, recognized by neither service as the threat it represented. German technical intelligence provided warnings that were similarly ignored. Late 1943, the Luftwaffe's Technical Intelligence Branch, AFT, after examining captured Allied bombers and downed aircraft, transmitted detailed assessments to Tokyo, describing American turbo-supercharger capabilities. Luftwaffe engineers, having struggled against high-altitude B-17 and B-2 for formations over Europe, understood exactly what these systems meant tactic. Ally. According to communications intercepted and decrypted by Allied intelligence and declassified in 1960, German advisors explicitly warned their Japanese counterparts in January 1944, American altitude advantage over Europe approaches 1,000 meters beyond our interception ceiling. Their new heavy bomber, reportedly designated B-29, will exceed even these capabilities. Urgent development of high-altitude fighters and advanced anti-aircraft systems is critical. The response from Japanese military leadership was tepid at best. Resources in early 1944 were already stretched impossibly thin across multiple theaters, defending the expanded Pacific perimeter, supporting operations in China, replacing carrier aviation losses from Midway and subsequent battles, developing entirely new categories of fighters and anti-aircraft. Systems would require sacrificing production of existing types that commanders considered adequate for current threats. As captured planning documents reveal, the consensus view held that American bombers, if they reached Japan at all, would operate at altitudes similar to raids against Germany, challenging but not impossible to contest. The most damning intelligence failure involved available public information. American aviation journals like Aerospace Engineering and Aviation Week published articles throughout the 1930s and early 1940s describing turbo-supercharger development, complete with performance data and technical specifications. These publications circulated legally in Jap, and until December 7, 1941, available to any engineer who could read English, yet the strategic implications were never synthesized into actionable military intelligence. The technology that would devastate Japan had been hiding in plain sight, discussed openly in technical literature for over a decade before the first B-29 appeared. The failure lay not in espionage or code-breaking, but in institutional inability to recognize revolutionary technological change unfolding openly before them. April 29, 1945 brought Staff Sergeant Henry Carlson's 25th and final B-29 mission, a distinction that earned him passage home under rotation policies, flying as flight engineer aboard City of Los Angeles. Carlson monitored the 4 turbo-supercharger systems that defined his aircraft's dominance. His logbook, donated to the National Museum of the Pacific War in Fredericksburg, Texas, contains matter-of-fact entries. No. 3 turbo running hot, adjusted wastegate. No. 1 turbo oil pressure fluctuating, monitored closely. All engines maintained boost pressure to 32,000 feet. Target destroyed, no fighter opposition. Behind these technical notes lay profound human experiences, both for American crews flying in stratospheric safety and Japanese defenders straining futilely below. For B-29 crewmen, the turbo-supercharger system represented the thin margin between life and death, though they rarely articulated it so dramatically. Technical Sergeant Robert Morgan, a flight engineer with the 73rd Bomb Wing, explained in a 1990 oral history, We knew the turbos were what kept us alive. They let us fly where the fighters couldn't reach, where most of the flak couldn't touch us. Every mission, I watched those turbine temperatures and de-boost pressure gauges like they were crystal balls. If the turbos failed and we had to descend, we'd be in the meat grinder with everyone else. The psychological comfort of altitude translated into measurably better crew, performance steadier nerves, more accurate bombing, fewer panic-induced errors. The pressurized cabin environment that Turbo-Superchargers enabled created surreal disconnection from the violence below. Captain Robert Raymer, bombardier aboard Thunder and Lorraine, described the cognitive dissonance in his 1948 memoir. We cruised in shirtsleeve.com. Fort at 30,000 feet, drinking coffee, breathing normally, warm despite outside temperatures cold enough to freeze flesh in seconds. Below, we could see fighters clawing upward, leaving black exhaust trails as they pushed engines to failure trying to reach us. Cities burned, people died. But in our pressurized cocoon, insulated by technology, it felt almost abstract, like dropping bombs on a map rather than on human beings. Japanese experiences formed the inverse of this technological isolation. Flight Sergeant Isamu Sasaki, flying Kawasaki Ki-61 fighters with the 244th Sentai, recorded his mounting frustration in letters to his family that survived the war. We scramble when radar detects them, climbing desperately toward the silver crosses that crawl across the sky far above. The engine screams go. Cues enter red zones. The airframe shudders with strain. At maximum altitude, breathing bottled oxygen through masks that frost over. Fingers going numb despite gloves, we watch them sail serenely onward, untouchable as clouds. Then we descend, fuel exhausted, mission failed again. I have flown 19 intercept attempts. I have not fired a single shot at the enemy. The ground crews and anti-aircraft gunners experience similar helplessness with different particulars. Corporal Hiroshi Tanaka, serving a Type 88 75mm anti-aircraft battery defending Osaka, wrote in his diary on March 13, 1945, "The bombers appear as tiny glints at the apex of the sky, impossibly high. We train the guns upward until barrels point nearly vertical. Calculate firing solutions with our best mathematics and send shells clee. Impinging into the stratosphere. 30 seconds later, distant black puffs appear hundreds of meters from the targets. The Americans don't even adjust course. They know we cannot touch them. We fire anyway because orders demand it, wasting ammunition we can barely replace. Going through motions of defense when true defense became impossible the moment those aircraft achieved their altitude. Civilians understood the technological disparity through its effects rather than its causes." Kimiko Nakamura, a schoolteacher in Kawasaki, recorded her observations in a diary subsequently published as part of a 1953 oral history collection. The children ask why our fighters don't stop the BNA Jukyu. How can I explain that the Americans fly where our aircraft can? Outreach? The concept seems impossible. Surely if our planes have wings, they can climb as high as needed. But day after day, we watch the silver formations crossing overhead unchallenged, and the terrible truth becomes undeniable. The enemy possesses some advantage we lack, something fundamental that renders our bravest pilots powerless. This knowledge, more than the bombs themselves, crushes our spirit. The human cost extended beyond combat casualties to psychological trauma on both sides. American crews, protected by technology from direct retaliation, nonetheless, suffered breakdown rates from the strain of repeated missions over increasingly desperate defenses. Japanese defenders endured the compounding stress of repeated failure, climbing day after day toward the enemies they couldn't reach, watching cities burn while possessing neither the tools nor the hope to intervene effectively. The turbo-supercharger created asymmetric warfare in its most psychologically damaging form. One side protected by technological advantage, the other reduced to futile gestures of resistance that everyone recognized as meaningless. War reduced to industrial process, humanity compressed by the remorseless logic of engineering superiority. September 2, 1945 aboard, the battleship USS Missouri anchored in Tokyo Bay. Japanese Foreign Minister Mamoru Shigemitsu signed the instrument of surrender that formally ended World War II, as he affixed his signature with a trembling hand weakened by W. Our time injuries overhead, the sky filled with hundreds of B-29 superfortresses in a massive victory flyover. They cruised at moderate altitude that day, no longer requiring the stratospheric sanctuary that had defined their dominance. The Turbo-Superchargers' strategic revolution had achieved its ultimate purpose. Japan's complete capitulation through air power that defenses could neither contest nor deter. The post-war analysis of strategic bombing's effectiveness generated controversy that persists decades later, but certain conclusions proved indisputable. The United States Strategic Bombing Survey, a comprehensive study conducted immediately after Japan's surrender, concluded that even without atomic weapons, conventional B-29 raids would have forced Japanese capitulate. By November 1945 through cumulative destruction of industrial capacity and transportation infrastructure, according to the survey's summary report, published in July 1946. The superiority of American bomber altitude performance, primarily attributable to turbo-supercharger technology, reduced Japanese air defenses from effective opposition to marginal harassment, enabling systematic destruction of target sets that rendered continued war physically impossible. The technological advantage translated directly into casualty ratios that validated pre-war strategic bombing theory. Of the approximately 33,000 B-29 sorties flown against Japan between June 1944 and August 1945, fewer than 500 aircraft were lost to all-causes Japanese fighters. Anti-aircraft fire, mechanical failure, and operational accidents combined. This represented a loss rate below 1.5%, remarkably low for sustained strategic bombing campaigns. By comparison, British night raids against Germany suffered loss rates frequently exceeding 5%, while unescorted American daylight raids in 1943 approached catastrophic 10% losses. The difference lay almost entirely in the B-29's ability to operate beyond effective defensive reach. Japanese defensive aviation was ground down through attrition rather than combat. Post-war analysis of Japanese records revealed that aircraft losses from operational accidents during futile interception attempts exceeded combat losses from B-29 defensive fire. Pilots pushed engines past design limits during desperate climbs, resulting in mechanical failures. Others lost consciousness from hypoxia at extreme altitudes, or suffered hypothermia-induced impairment that led to navigation errors and fuel exhaustion. Lieutenant General Takashi Takagi, commanding the Japanese Army's air defenses from April 1945, acknowledged in 1952, "We destroyed ourselves attempting to reach an unreachable enemy. For every bomber we damaged, we lost 3 fighters to accidents and pilot exhaustion." The mathematics of this exchange made defense unsustainable within months. The Turbo-Superchargers' influence extended far beyond World War II into subsequent aviation development. Post-war commercial aviation adopted pressurization and high-altitude cruise as standard features directly. Descending from B-29 technology, the Boeing 377 Stratocruiser, which entered airline service in 1947, was essentially a wide-body variant of the B-29 fuselage and wing, complete with turbo-supercharged engines and pressurized passenger cabin. Modern jet airliners cruising routinely at 35,000 to 40,000 feet represent the ultimate evolution of the strategic principle. The B-29 demonstrated that altitude provides both efficiency and safety. Military aviation embraced the lessons even more explicitly. The development of jet engines, which inherently perform better at high altitude than piston engines, accelerated dramatically after the war. The Boeing B-47 and B-52 jet bombers, entering service in the early 1950s, were designed from inception to operate at stratospheric altitudes beyond phi. Gator interception, a strategic concept vindicated by B-29 experience. When surface-to-air missiles eventually made high-altitude penetration untenable by the 1960s, bombers shifted to low-level tactics. But modern stealth technology represents yet another way to achieve the same goal: striking without effective opposition. On September 21, 1995, Boeing marked the 50th anniversary of the B-29's first flight with a ceremony at the company's Seattle facility. Among the speakers was retired Lieutenant General Eugene Eubank, who'd commanded B-29 operations from Guam. "We honor the superfortress," he told the assembled audience of veterans and aviation historians, but we should equally honor the invisible technology that made it supreme, the Turbo-Supercharger. That unglamorous piece of machinery, hidden in engine nestles, gave us altitude. Altitude gave us survival. Survival gave us time to perfect bombing accuracy. AC. Accuracy gave us strategic effectiveness. Strategic effectiveness gave us victory. The silver bombers that dominated Japanese skies in 1945 had retired decades before, but their legacy endured in every pressurized aircraft that pierced the stratosphere, each one a testament to Sanford Moss's vision and the engineers who transformed exhaust gases into strategic dominance. Writing history from altitudes Japan never imagined bombers could reach,